Okay, it looks like we're recording. Time for another Trig Nibble. This one's Trig Nibble, figuring out trig functions by hand. And this is based on a question I got from a student. I am a supplemental instruction leader for Indiana University East, at least at this point when I'm recording this video. And the student says, I have trouble figuring out when the question asks for us to figure out the trig functions by hand. I have trouble. Is there a way I can learn this? And yes, you can. And very little memorization, so little I'd say none. So let's go to the screen. Let's hop right in. Otherwise, it won't be a nibble. It'll be a epic. Okay, can you see my screen? So look all the way right now to the right, and it says, once you have sine and cosine, you are all set. Just remember that. If you've got sine and cosine, you can figure out all the other functions. And don't forget, theoretically, there are a lot of other, if you have cotangent, you have tangent. If you have cosecant, you have sine. You can figure these things out, those type of things. So once you have sine and cosine, you're all set. You only care about the angular distance from the x-axis and the quadrant. Remember that too. All you care about when you're figuring out these things by hand, what is the angular distance, how many degrees, how many radians from the x-axis are you? You don't care if at this point of whether it's above or below the x-axis and it's on the left or, I went the wrong way, on the left or the right of the y-axis, just how many degrees or radians away from the x-axis. And then the quadrant. Then you care about it. Essentially, there are only 5 angles, 5 values, basically values that cosine and sine can be, absolute values I should say. Here, let me add that right there. Let's go here, 5 absolute values for sine and cosine, 4 quadrants, so you can know negative and positive, and 2 triangles you care about. Now this is probably sounding like more than it is. When we jump in, you'll see it. And just remember that trig functions are ratios that hold true no matter whether you have a little triangle or a huge triangle. Sine of 30 degrees is always going to be sine of 30 degrees, no matter how big or how small that triangle is. That means you should give a big hug to the unit circle when you're trying to figure things out. Okay, let's go ahead and look at it. So the 5 angles that you care about are 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. If they're going to ask you to do it by hand, it's essentially one of those. Or 0, pi over 6, pi over 4, pi over 3, or pi over 2 if you like radians, and I actually do like radians. And then the values, the only values you'll ever see doing that, absolute values I should say. Yep, I should say absolute here again, absolute. Okay, are 0, 1/2, square root of 2 over 2, 1, and square root of 3 over 2. And now let's look at why those are the only values, okay? In essence, if you've got your xy axis, okay, and you do 0 degrees, 90 degrees, 180, oops, can't write, 180 degrees, 270 degrees, and of course this is 0 radians, this is pi over 2 radians, this is pi radians, and this is 3 pi over 2 radians. If you know, remember I told you to embrace the unit circle, so let's just go ahead and do that here, right? We know with a unit circle that the radius is always 1, which means if it's 1, that if you have a right triangle and you've got this equal to 1, this is going to be, well, this would be true either way. If you draw your right triangle here, you know that your ratios, this is going to be y, this is going to be x, right? So opposite equals y, adjacent equals x. Do you have that? Opposite is y, adjacent is x. And we know that sine equals opposite over hypotenuse, and cosine equals adjacent over hypotenuse, right? But what do we say that the radius always is? And the radius is the hypotenuse is always 1. So when you're using the unit circle, sine equals opposite, which equals y. Cosine equals adjacent, which equals x. Oops. Cosine equals adjacent, which equals x. Why is that important? Because you can tie the two together. Remember, we're doing the unit circle. It doesn't matter if you suddenly draw a circle that's way out of there. Whatever you would have figured out for this smaller triangle here, this one limited by the unit circle, that's going to be true for the gigantic one that goes way out here and ends up like this. It's going to be the same. Okay. So now let's look back at our triangles. Well, actually, before that, let's say you have 0 degrees, just for argument's sake. If you have 0 degrees, what's happening to y as you move closer to 0 degrees? Can you see that? When you do that, as you're getting closer to the x-axis, y is getting smaller and smaller and smaller, and you know at 0 degrees what x is. X is 1, right? So let's say we say sine, well, actually, let's do it this way. Let's take 0 degrees. We're going to scan down here. We'll have to go back up in a minute. So let's go with 0 degrees. I told you you only have, so I'm sorry, I'm jumping back and forth here. Let's go back here real quick here. Let's go back up here. I said these are the only angles that you care about. Trust me. That's what they're always asking about. You might see them in this form, in radians form, but that's always what the angles are when you look at the distance from the x-axis. Remember what I said up here? You only care about the angular distance of the x-axis. They're always that distance from the x-axis. Otherwise, it'd be pretty hard to ask you to do them manually, unless they give you the size of the triangle. In this case, they're giving you the angles. Okay, so let's say we have 0 degrees. You can see at 0 degrees, x is 1, y is 0. So there you go. You got your first set, 0 degrees. Sine, cosine. Okay? Sine, y is 0. Cosine, 1. And something else to remember, sine and cosine can't be bigger than 1 or less than negative 1. As is, obviously, if you multiply something times them. But as is, that's the largest or smallest they could be. Okay? Now, let's go ahead and just to make it easy, let's go right to 90 degrees. Now what's happening to y? With 90 degrees, y is getting closer this way. Y is getting bigger and bigger and bigger. But what's the most it can be? What did we just say? It can be 1. So we know that at 90 degrees, that y equals 1 and x equals 0. So now if you go to 90 degrees, we know that sine is 1 and cosine is 0. So just think about it. You notice how, here, I drew up these pairs. These are the values you need. Let me explain why. These are the values, but notice they come in pairs. It's either going to be 0, 1 or 1, 0. They're not matching all kinds of different numbers. If you see a 0 for one, it's going to be a 1 for the other. If you see a 1 for one, it's going to be a 0 for the other. Same thing with this one. If you see square root of 3 over 2, the next one's going to be 1/2. If you see 1/2, the other one's going to be square root of 3 over 2. And then finally, square root of 2 is always square root of 2 on both, and you're going to see why. Okay, now you can see why the 0 and the 1 are pairs, right? Let's keep it simple. Let's go with 45 degrees next, okay? So we're going to go with 45 degrees. Okay, I told you, two triangles. 45 degree triangle, 45, 45, 90 degree right triangle is 1, 1 square root of 2. It's pretty easy. Let me put it this way. You might as well choose 1 because 1's easier to work with than other numbers. You have to choose 2 equal numbers other than 0. You got to choose 2 equal numbers, choose 1. 1, 1, and then you know by Pythagorean theorem that, you know, a squared plus b squared equals c squared. Well, to figure out c squared, 1 squared plus 1 squared equals c squared. C equals the square root of 1 plus 1, 2, right? There you go. Okay? So now, just remember that triangle. See this triangle? This one right here. This triangle right there. Just remember that, okay? That's a 45, 45, 90 triangle, or pi over 4, pi over 4, pi over 2 triangle, okay? So now if you want to know what your sine and cosine are, they're the same because they both opposite and adjacent are the same on both. So this is always, whoops, come back down here, slow scroll, okay? It's going to be, well, think of it this one. It's going to be 1 over the square root of 2, right? Opposite or adjacent over hypotenuse, you know, adjacent over hypotenuse. So use that triangle. And now you're going to say, hey, Alan, but you're using in the unit circle, it couldn't be the square root of 2. Look at the triangle. All we're trying to do right now is say, if you want to know what the value is for 45 degrees, use that. Use the unit triangle to figure out the x and y when it's 0 or 90. It's very handy because you know it's going to be the same. But with 30, 60 degree, and 45 degree, it's easier to just do these two triangles, and then we'll figure out about it. Okay. So now 45 degrees. We don't like irrational numbers, so we rationalize. So 1 square root of 2 times square root of 2 over square root of 2 equals square root of 2 over 2, right? That's what we want. So both of these, sine and cosine, are square root of 2 over 2. Okay, let's talk next about the 30 degree angle. Okay? So notice this triangle up here. Okay? A 30, 60, and this is about the only one I would say kind of have to memorize. Because I can't tell you a logical reason why it would be automatically this way. There may be one, I just can't think of it. But the 30, 60, 90 triangle has 1 on one side, the hypotenuse is 2, so 1 on one side, and then if you do the reverse of what we were doing over, where are we? Where do we do the Pythagorean theorem? If you use the Pythagorean theorem again, you're going to figure out this has to be square root of 3, right? Okay. Remember, the 30, 60, 90 triangle is the 60, 30, 90 triangle. The 60 and 30 degree angles are attached at the hip. That's why you only have the two values. Notice, if you take this triangle, there are only two values you can get from it. 1/2 or square root of 3 over 2. For sine and cosine, that is, right? If you're at the 30 degree angle, if this is your angle of interest, then you know that the smaller side has to be opposite the 30 degrees, right? Because if that wouldn't make sense that a larger side would be opposite the smaller angle. Does that make sense? It would not be there. You wouldn't, exactly. You wouldn't, if this is 1, you wouldn't expect 60 degrees to be 1/2. Why would it be smaller? So just remember that. The larger side is across from the larger angle. The smaller side is across from the smaller side. And so when you want to figure out sine, cosine, those kind of things. So let's get back to this. So there's our triangle. And you look at 30 degrees. Well, opposite is 1. Well, I'm sorry, I have one of these mice that scrolls without any push. Then if you think about 30 degrees, the smaller side, that's going to be 1 over 2, 1/2. The 30 degree cosine is the adjacent side. That's square root of 3 over 2. Okay? And then what's neat is 60 degrees is just the opposite. If you got 60 degrees, the opposite side is square root of 3 over 2. And then the adjacent side is 1 over 2. So do you see what I'm saying? 5 values, 5 angles, and only in all of these, and these values, there are only 5 absolute values. There are only 5 absolute values. Okay? So can you memorize, if you have to memorize, can you memorize those 5 values and then figure out where you got to stick them? Probably, but that's why this triangle is kind of obvious. You can rebuild it. You got to have 2 sides. They got to be even. Use the Pythagorean theorem. This one here, okay. Yeah, memorize. It's 1, 2, square root of 3. Just memorize that. You got those 2 angles down there. You're golden. Okay. So now I've given it so that you can do the absolute value. But it's not going to do you much good when somebody comes to you and they say, hey, I have, let's go with, I have 7 pi over 6. Figure out cotangent by hand. We'll complicate it just a little bit. Okay? That's what they want. Okay, well, good news is it's really easy. First, before we get started, if I draw the quadrants, I got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Oops. And quadrant 4, we've said, this is y, this is x, we've said that sine is tied to y and cosine is tied to x. So if we do that, in quadrant 1, sine is positive, quadrant 2, sine is positive, right? This side here. Okay, in quadrant 3, sine is negative, it's down here. And then in quadrant 4, sine is negative. What about cosine? Quadrant 1, cosine is also positive. And in quadrant 2, look, cosine is now on the right. It's negative. Cosine is negative. And again, you should be able to do this. You don't have to memorize this. You should be able to do this, right? Just draw your thing. You know what the xy goes. Positive, positive, that kind of stuff. In this one, we've got cosine negative. And then in this one, cosine is positive. And then let's go ahead and do tangent, because in essence, then you have 3 and you just flip them for the other ones, right? Well, in this case, if we go with tangent, tangent is sine over cosine. So tangent is positive. In this one, as soon as you have one negative sign, not two negative signs, right? There you go. Okay? You can figure everything out. So let's go back to 7 pi over 6, okay? Let's draw that real quick. We already said 0, 90. We're going to do it this way. We're going to go 0, pi over 2, pi, 3 pi over 2. And they said 7 pi over 6. So if you think about it, 7 pi over 6 is 6 pi over 6 plus pi over 6, okay? Right? And the reason you do it that way is what you're trying to do is tie it to something that you can break into the x-axis, right? And basically, you can remove pi's or remove 2 pi's, or you can move 3 pi's. You know what I mean? You can kind of see where it is, and sometimes that'll cause you to be negative, positive, whatever. Won't matter. So we come over here. If you do 7 pi over 6, this is 6 pi over 6 right here. So 7 pi over 6 is just a little bit here. We have a distance of pi over 6. Does that make sense? Got that? So this is 7 pi over 6 right here. But what did I say up here? You only care about the angular distance to the x-axis. So even though I've got 7 pi over 6 thrown at me, all I care about is this pi over 6. Well, what is pi over 6, right? Pi over 6 is a 30-degree angle. And we've already got our triangle. And I actually draw these out just so that I'm okay. Now again, remember, this is a 30, 60, 90, right? And pi over 6 is the smaller one. So where would that go? Think about it just for a second. Is it going to go up here? No, because the larger side. So is it going to go up here? No, because the larger side's here. So this is where pi over 6 is, right there. Which means that if you want to know what the... Now you've asked for cotangent. Just figure out sine and cosine first. It's just a lot easier, okay? So the sine is going to be... Absolute value of sine is going to be 1 over 2. The absolute value of cosine is going to be square root of 3 over 2. Okay, now we take our magic quadrants and we say, now that we know the absolute value, the reference angle, which some of you are studying when I'm recording this, actually all of you should be studying it this week as I'm recording it, all of the ones in the classes that I'm SIing for. What's the sine, or is it positive or negative? Okay, sine. Look over here. It is this quadrant right here. Right here. What is sine? Sine is negative. What is cosine? Cosine is negative. Right there. See that? Sine is negative. Cosine is negative. Okay? Got that? Pretty simple. Now what's cotangent? Whoops. Yeah, you know, if you have an eraser, there's no reason to just write over it, huh? What's cotangent equals cosine over sine. Tangent, of course, equals sine over cosine. Okay, so now you've got... Well, okay. We're going to do two things. I'll show you one shortcut that you could do. So you've got negative 1/2. Well, actually, the top is cosine. So cotangent equals cosine over sine. So you have negative square root of 3 over 2 over negative 1/2. Agreed? right there. Okay, now here's the shortcut. I like using the sine and cosine, but I guess if I was doing this on an exam, I might do this too. We could have just figured out cotangent, because cotangent not only is cosine over sine, cotangent equals adjacent over opposite, right? Adjacent is square root of 3, opposite is 1. So again, then you have your absolute value. Got your absolute value is square root of 3. Now you got to look at the sine of this, and just think of it this way. If you go back up in your quadrants, if tangent's positive, so is cotangent, right? And it's the same reason. So that would have been more simple, I guess. I guess part of the reason I went the other way is they're usually going to ask you for all 6 values, right? So you're going to have to figure out sine and cosine generally. But yeah, as you get to this point, I guess if somebody literally did ask you for this, figure out cotangent by hand, I would draw this triangle, and then I'd figure out what was adjacent and what was opposite, do the division, and then finally I would look at the quadrants. Does that make sense? Does that help? If it doesn't, go ahead and say it. I mean, part of the problem is that when I'm doing a session, I can talk and get feedback back and forth and tweak what I'm saying to make sure people understand it. Here I can't. And it may be something that works well for my brain, doesn't work well for your brain, and that doesn't mean your brain is wrong. It probably means my brain is wrong. But either way, if you want to get a hold of me, if you're with Indiana University, well, actually, you can hit me at afarner, A-F-A-H-R-N as in Nancy, E-R, at iu.edu. And by the way, it's A, F as in Frank, afarner. You can also get me at Alan at math.promo, A-L-A-N, at math.promo. Okay, that's it. This is longer than I expected, but there's so much simple things. Let's focus on the summary. There are only 5 angles you care about, and there are 5 absolute values for sine and cosine. After that, you're just figuring out, and then of course the 2 triangles you care about. After that, you're just figuring out what's the value for sine, what's the value for cosine, absolute value, and then what's their sine. And with the quadrants, and folks, if I can say it over and over and over again, don't hesitate to draw things out. Draw the triangle. Somebody gives you one of these problems, draw the triangles. You know, obviously if it's 90 degrees, the equivalent of 90 degrees or 0 degrees, you're not going to draw a triangle, but then you know it's basically if it's 90 or 0, and by the, let's just talk about real quickly like this. This, where's my thing here? This is obviously 0. This is the equivalent of 0. This is obviously 90 degrees. This is the equivalent of 90 degrees. The only thing that changes are the sign being positive or negative things, okay? So that's what I mean about 1 and 0. Draw the triangles, draw the XY axis, draw the unit circle. Just, especially, you know, you might say I'm in a rush on a test, but you want to slow down and make sure you're not making mistakes. And I've done things like that where I might have 1/2 on the brain when it should have been square root of 3 over 2. You know what? You draw this out, there's no way you're going to make that mistake. You draw your little quadrant thing, positive, negative with your quadrant, there's no way you're going to remember the wrong thing. Thanks for watching. See you again next time.